have astronomers just uncovered something inside Andromeda that changes the way we see our nearest galactic neighbour forever. What Hubble discovered is not just beautiful, not just strange, but deeply unsettling. Hidden inside that vast spiral of stars are clues pointing to ancient collisions, vanished galaxies, and a history far more violent than anyone once imagined. If that sounds fascinating, please take a moment to like this video, subscribe to the channel, and share it with someone who loves the mysteries of space. Thank you so much for being here and for spending this time exploring the universe together. And before we begin, it would be lovely to know, what time is it where this is being heard, and from which part of the world is it being watched? Now, let us step into the light of Andromeda and discover what Hubble found hidden inside. What hangs in the dark near the constellation of Andromeda does not first appear as a galaxy. It appears as a stain, a dim patch, a soft interruption in the scatter of stars. For most of human history, that is all it seems to be, a faint blur with no sharp edge, too diffuse to behave like a planet, too fixed to behave like a cloud, too quiet to force an answer. Ancient sky watchers record it because it stays. In the year 964, the Persian astronomer Abd al-Rahman al-Sufi includes it in his work on the fixed stars and describes it as a small cloudy patch. The phrase sounds modest, but what it points to is not. A cloudy patch in the heavens is an invitation to underestimate distance. That mistake lasts for centuries. The object remains visible to the unaided eye under dark skies, but it reveals almost nothing more. It does not twinkle like a nearby star. It does not spread like the Milky Way. It simply hangs there, quiet and unresolved, as though the night itself has thickened in one small place. Seen from Earth, Andromeda is broad enough to stretch across several full moons, yet its light is spread so thin by distance that the eye reduces it to a hesitant smear. Even this first appearance contains a hidden shock. Something so faint can still be immense. When telescopes begin to change astronomy, the patch does not surrender easily. In the early 17th century, Simon Marius turns one of the first telescopes toward it and sees not a point but a pale glow that grows brighter toward the middle. The centre looks dense, almost gathered around a secret. This is progress, but only a little. Many things in the sky become clearer under magnification. Andromeda remains stubborn. It refuses to break cleanly into stars. It refuses to reveal enough structure for certainty. For generations, astronomers return to it and meet the same result, more detail, but never enough to settle the larger question of what it is. By the 18th century it enters catalogues of nebulae. Charles Messier gives it the name Messier 31. The label places it on a list, but not inside an explanation. Some fuzzy objects later prove to be clouds of gas inside the Milky Way. Others seem stranger. They show hints of symmetry and design, hints that they may be systems rather than clouds. But distance keeps the truth hidden. A faint object can be small and near, or vast and unimaginably far. Without a dependable way to tell the difference, the universe keeps its true scale concealed. In the 19th century the mystery deepens. William Parsons, the 3rd Earl of Rosse, builds the Leviathan of Parsonstown, a telescope so large that it changes what the sky can show. With instruments like this, some nebulae begin to reveal spiral forms. That is unsettling. A cloud does not naturally arrange itself into a grand whirl. Structure suggests order, and order suggests motion of a very specific kind. Then Isaac Roberts photographs Andromeda, and the image preserves that spiral shape with new force. The problem sharpens at once. If Andromeda is a spiral, then what exactly is spiraling at first? One answer seems safe. Perhaps it is part of the Milky Way. a rotating cloud within the home galaxy itself. That explanation keeps the universe modest. But the more astronomers study spiral nebulae, the less comfortable that answer becomes. These objects do not behave quite like the stars around them. They seem detached from the local order. Slowly, suspicion grows that the night may contain not one galaxy, but many. Not one island of stars, but an ocean filled with islands so distant that even the largest telescopes catch only their outer light. This leads to one of astronomy's most important uncertainties. Are spiral nebulae local structures within the Milky Way, or are they separate systems far beyond it? It is not just a technical question, it is a question about the size of reality. If Andromeda lies within the Milky Way, then it is part of home. If it lies beyond, then home is only one structure among many. The difference is almost too large to think about. The cloudy patch suddenly becomes a border test for the known universe. The answer begins to emerge through a class of stars called Cepheid variables. These stars brighten and dim in a regular rhythm, and that rhythm reveals their true brightness. Once that brightness is known, distance can be inferred by comparing it with how faint the star appears from Earth. Edwin Hubble identifies Cepheid variables in Andromeda and uses them to calculate a distance so great that the older picture can no longer survive. Andromeda is not a cloud inside the Milky Way. It is a galaxy beyond it. The dim patch seen for centuries is a city of stars outside the city that contains the Sun. The shock of that realization is difficult to overstate. What once looked like a blur becomes a structure roughly 150,000 light-years across, holding perhaps as many as 1 trillion stars. The light arriving at Earth has crossed about 2.5 million years of space. Every glimpse of Andromeda is delayed. Its visible form belongs to a past so distant that what appears calm in the sky is already ancient by the time it is seen. Yet this certainty does not feel like an ending. It feels like the beginning of a larger unease. Once Andromeda is recognized as a galaxy, new questions immediately gather around it. Why does its center shine so fiercely? Why do its spiral arms look elegant from a distance but unsettled when examined more closely? Why does this neighboring system seem both orderly and disturbed at the same time? Later observations will reveal dark lanes of dust, crowded star fields, close companion galaxies, and strange streams of stars that seem to remember all disruptions. But even before those discoveries, the deeper mystery is already there. If one faint smear turns out to be another galaxy, then the night sky is no longer a ceiling decorated with lights. It is depth without obvious limit. Andromeda begins as a blur because distance hides complexity. It becomes compelling because every improvement in vision uncovers not simplicity, but history. A cloud can be simple. A galaxy cannot. A galaxy carries births, collapses, migrations, and collisions across billions of years. The pale patch recorded by early observers is not a static feature of the sky at all. It is a vast structure of gravity and time, turning beside the Milky Way in the dark. At first it seems remote enough to be harmless, almost abstract. But the moment it is understood as another galaxy, it stops being scenery. It becomes a neighbour. And neighbours can carry stories close enough to matter. Once Andromeda is accepted as a galaxy, the next problem is seeing it well enough to understand what kind of galaxy it actually is. That turns out to be harder than naming it. A distant spiral can look serene from far away. Its broad shape can suggest balance, even inevitability, as though gravity has arranged everything into a graceful final form. But distance also smooths away trouble. It merges crowded regions into a single glow, erases the fine edges of dust lanes, and turns countless stars into haze. The more astronomers learn about galaxies in general, the more they realize that appearance from a distance can be deceptive. A galaxy may look calm and still while carrying the marks of old collisions, bursts of star formation, wandering black holes, and entire populations of stars born in different ages under different conditions. To understand Andromeda, it is not enough to see its outline. The structure inside the outline matters. For a long time, Andromeda offers only partial views. Ground-based telescopes capture its full sweep across the sky, but Earth's atmosphere blurs the smallest details. Infrared telescopes uncover dust and star-forming regions hidden from visible light. Ultraviolet observations reveal hotter, younger stars. Radio instruments trace gas spread across the disk and beyond it. X-ray observatories find the signatures of compact objects, dead stars, violent accretion, and activity near the center. Each wavelength tells a different part of the story, and each new image seems to prove that the galaxy is more layered than it first appears. Yet there is a tension in all of this. The larger the field of view, the less detail each region can hold. The finer the detail, the smaller the portion of the galaxy that can be covered. Andromeda is too large to fit easily inside one sharp portrait. That is part of what makes the Hubble Space Telescope so important in this story. Hubble is not built to capture enormous swaths of sky in a single frame. It sees with extraordinary sharpness, but over a relatively narrow window. To image a galaxy as wide as Andromeda in deep detail, it must work piece by piece, patiently, over years. That patience becomes the method, instead of trying to seize the whole galaxy at once. Hubble collects it fragment by fragment, orbit by orbit, each exposure adding one more tile to a mosaic too large to imagine at the beginning. The process is slow enough to feel almost geological. It is not a snapshot, it is an excavation. The result arrives after a decade of observation and assembly. More than 1,000 Hubble orbits are used. More than 600 separate snapshots are combined. The final image reaches roughly 2.5 billion pixels. It is not simply large, it is dense with information. Within that enormous portrait, Hubble resolves around 200 million individual stars, not star clusters mistaken for points, not patches of blended glow, individual stars. At a distance of about 2.5 million light-years, that achievement is almost unsettling. The old blurred neighbour is suddenly granular. It breaks apart into countless distinct lights, each one a sun in its own right. This change in scale is where the psychological shock begins. A spiral galaxy seen from afar can be treated as an object. A galaxy resolved into stars becomes something else. The eye starts to understand, not just abstractly but almost physically, how large the system really is. Each visible point is likely to have its own worlds, its own comets, its own cold outer debris, perhaps its own dead planets drifting in darkness. The mind begins to count and immediately fails. 200 million stars are only the ones Hubble can cleanly resolve in the mosaic. The total stellar population of Andromeda may approach 1 trillion. Most remain too dim or too crowded to separate. The image is therefore both overwhelming and incomplete. It is a census that makes absence as important as presence. The visible stars are astonishing, but the invisible majority deepens the mystery. If this is what can be seen, what remains hidden in the brilliance? The mosaic also changes how Andromeda's inner regions feel. In the outer disk, the eye can still trace dust lanes, pockets of blue star formation, and the texture of a large spiral system built from many local regions. Closer to the center, the stars crowd together until they no longer seem separate. The nucleus swells into a concentrated golden light so dense that it begins to look almost solid, as if individual suns have been compressed into a single luminous surface. This is an illusion produced by extreme crowding, but it carries a strange emotional weight. The center of Andromeda does not look empty or merely bright. It looks packed beyond comfort, as though too much history has accumulated in one place. This is where the portrait begins to do more than impress. It begins to challenge old assumptions. Andromeda is classified as a spiral galaxy, and from a distance that label appears to fit. It has a bright central bulge, a disk, and sweeping arms. But Hubble's view shows that the galaxy is not a clean version of a spiral. It is tilted almost edge-on from Earth, about 77 degrees, which means the eye is looking through layers of structure superimposed on one another. Dust lanes cut across starlight. Bright regions seem offset. The northern and southern parts do not feel perfectly balanced. The more closely the image is examined, the more it resists the idea of a simple textbook spiral. That resistance matters because Andromeda is often treated as a stand-in for the Milky Way. It is close, massive, and visible from the outside, which makes it useful as a kind of external mirror. The Milky Way is hard to study as a whole because Earth lies inside its disk, surrounded by dust, foreground stars, and uncertain distances. Andromeda offers a different vantage point. It allows astronomers to study a large spiral galaxy from outside as a complete system rather than a place being viewed from the middle. But Hubble's image complicates the comparison. If Andromeda were a simple twin of the Milky Way, its structure might look more regular. Instead, it looks like a relative with familiar features and a very different life story. This is where clarity turns into intrigue. Better data is supposed to reduce confusion. In Andromeda's case, better data exposes anomalies that were easy to miss when the galaxy remained soft and distant. The disk contains patterns that seem too ring-like in places and too disturbed in others. The brightest star-forming regions are not spread evenly. The southern side appears more disordered than the northern side. Dust does not lie where a neat model might expect it to lie. Some stellar populations seem to belong to different eras layered on top of one another. Even the beauty of the image starts to feel suspicious. The galaxy is magnificent, but not relaxed. Hubble's mosaic therefore works on two levels at once. On one level, it is a technical triumph, one of the most detailed portraits ever made of any galaxy beyond the Milky Way. On another, it is a warning that Andromeda may be stranger than its famous spiral silhouette suggests. Every resolved star contributes to a grander picture, but the grander picture does not settle down into certainty. It starts to look like evidence. A galaxy that once served mainly as proof that other galaxies exist now begins to serve a different role. It becomes a record of disruptions that are not yet fully understood. And this is perhaps the most unsettling consequence of Hubble's new view. Distance had once made Andromeda feel safely abstract. The mosaic removes that safety. It shows a neighbouring galaxy in enough detail to make its internal history visible, at least in fragments. Once that threshold is crossed, Andromeda no longer appears as a remote decoration at the edge of human vision. It appears as a system that has been shaped by events, some graceful, some violent, some still not fully explained. The sharper the portrait becomes, the less passive the galaxy seems. It begins to look like a place where something has happened, perhaps more than once, and where the visible order is only the surface of a much rougher past. The first region that truly unsettles the neat picture of Andromeda lies not at its centre, but farther out in the disk, where new stars gather in a broad ring. At a glance, the galaxy appears to have spiral arms like so many other large spirals. But when Hubble's detailed survey begins to separate the light into individual populations, another pattern takes shape beneath the familiar outline. Instead of a smooth spread of starbirth across the disk, there is a striking concentration in an elliptical band roughly 10 kiloparsecs from the nucleus. It is not invisible in earlier images, but Hubble makes its character impossible to ignore. The region glows with clusters of young, hot stars whose blue light cuts through the warmer tones around them. It looks active, fresh, almost orderly. Yet the more clearly it is seen, the less ordinary it becomes. This ring is one of the most important products of the panchromatic Hubble Andromeda treasury. The long campaign that maps a huge portion of Andromeda's star-forming disk across wavelengths ranging from near ultraviolet to near infrared. The value of this approach is not simply aesthetic. Different wavelengths reveal different layers of the galaxy. Ultraviolet light highlights hotter, younger stars. Visible light shows the crowded stellar field and the broad dust pattern. Infrared helps astronomers see through part of the dust and trace cooler structures that would otherwise remain obscured. With all of these views combined, the ring begins to emerge as more than a bright feature. It becomes a clue. The stars inside it are not just young. Many are richer in heavier elements than expected for such a dramatic outer structure. In astronomy, anything heavier than hydrogen and helium is treated as a metal, and metal-rich stars usually imply that the gas from which they formed has already been processed by earlier generations of stars. That matters because it means this ring is not simply a primitive fringe of untouched material lighting up for the first time. It forms from gas with history. It forms from matter that has already been through stellar furnaces, been enriched, and then gathered again into a new wave of birth. Even in its chemistry, the ring carries the sense of aftermath. The visual impression is strangely deceptive. From far away, the ring can seem almost decorative, a bright band tracing the outer disk like a necklace of blue fire. Zoomed in, the effect changes. The band dissolves into crowded knots, streams, associations, and individual stars that seem to spill through the region in great numbers. Hubble's team compares them to grains of sand on a beach, and the comparison is apt because the eye loses all hope of easy counting. The closer the examination becomes, the less the structure resembles a single clean feature. It looks instead like a vast zone where conditions have favoured star formation on an exceptional scale, but not with the calm uniformity a simple model would predict. There are gaps, asymmetries, and places where the ring seems interwoven with other structures rather than standing cleanly apart from them. That is where the problem begins. In a classic spiral galaxy, star formation often traces the arms, where gas is compressed and new stars are born in waves. Rings can exist as well, especially in galaxies influenced by bars, resonances, or other internal dynamics. But Andromeda's ring does not sit comfortably inside the most obvious explanations. It is too prominent, too distinct, and too suggestive of a more violent origin. The simple image of a quiet spiral rotating through time starts to slip. The ring seems less like a natural decoration of the disk and more like a lingering response to an event. Before that suspicion becomes strong, astronomers are cautious. Galaxies are complex places, and not every unusual structure needs a dramatic cause. Gas can be shepherded into rings by gravitational patterns inside a galaxy. A central bar, even a weak one, can redistribute matter over time. Orbital resonances can collect gas in preferred locations. Seen from a distance and at an angle, spiral arms can sometimes imitate rings. These possibilities are not careless guesses. They're grounded in real galactic behavior. Yet with Andromeda, the evidence begins to lean in a different direction. The ring does not merely coexist with a spiral pattern, it seems to interrupt it. The deeper problem is that Andromeda does not behave like a galaxy growing in one smooth rhythm. Its star-forming disk appears layered, as though different episodes have left different signatures. Some regions suggest ordinary long-term evolution, others suggest disturbance. The 10 kiloparsec ring becomes one of the clearest examples because it is both vivid and difficult to explain away. A galaxy can host active star formation without inviting alarm. but a broad, offset, elliptical ring of young metal-rich stars around a massive neighbouring galaxy suggests that the gas of Andromeda has been pushed, compressed, and reorganised on a grand scale. Something may have struck the system hard enough to launch a wave through the disk. The thought is quiet at first, then increasingly difficult to avoid. In a pond, a ripple means impact. In a galaxy, the same logic is slower and far more complex, but the resemblance remains. If a smaller galaxy plunges through the disk of a larger one, it can drive density waves outward through gas and dust. Those waves can trigger star formation in expanding rings. The process is not instantaneous. It unfolds across millions of years. By the time telescopes observe the result, the intruder may already be elsewhere, dimmed, distorted, or stripped of its former mass. The ring remains as the delayed signature of an event no human observer could witness directly. This possibility changes how the blue stars are read. They are no longer merely evidence of recent birth. They may also be markers of a wound healing through light. A collision in a galaxy does not resemble a collision between solid bodies. Stars are so widely separated that most do not strike one another. Instead, gravity rearranges paths, while gas clouds compress, shock, and collapse into new generations of stars. The visible result can be paradoxical. Violence produces beauty. Disorder leaves behind structure. A galaxy hit by another can answer not only with distortion, but with a ring of brilliant newborn suns. Andromeda is especially compelling because the ring does not stand alone as an isolated curiosity. Even before the full picture becomes clear, there are hints that other unusual features may be related to it. Dust lanes appear offset. Some inner structures resist easy classification. The southern side of the galaxy seems more disturbed than the northern side. Streams of stars extend into the halo. The ring therefore begins to feel less like an exception, and more like one visible part of a larger pattern. Hubble does not invent that pattern. It sharpens it. Once the star-forming band is seen with enough detail, the entire galaxy starts to look less settled. There is also the matter of timing. Though here caution becomes necessary, a ring of star formation can preserve the echo of a past interaction. But not with the precision of a clock. Astronomers estimate ages, compare simulations, and weigh the likely motions of companion galaxies, yet uncertainty remains. The known fact is the structure itself, a broad ring of active star formation, where a calmer distribution might have been expected. The stronger interpretation is that the ring records an impact. Beyond that, the mystery widens. Which companion did it? When exactly did it happen? Was it a direct plunge through the disk, or one stage in a more complicated dance of repeated encounters? And if one ring can survive as a visible scar, how many other scars remain hidden in Andromeda's light? This is the moment when Andromeda's beauty begins to feel less innocent. Hubble's image does not merely show a neighbouring spiral filled with stars. It reveals a galaxy whose brightest youthful regions may have been triggered by disruption. The blue ring is not simply where Andromeda shines. It may be where Andromeda remembers. And once memory enters the picture, the galaxy ceases to be a still object suspended in space. It becomes a record of forces passing through it, leaving patterns that look almost graceful until their origin is considered. Then the ring changes. It is still beautiful, but it also carries the shape of an old disturbance spreading outward, not yet fully understood, still bright enough to demand an answer. The blue ring in the outer disk is not the only reason Andromeda begins to look less like a quiet spiral and more like the aftermath of something abrupt. As astronomers compare visible light with infrared observations, another structure emerges much closer to the centre, and this one is stranger in a different way. Near the nucleus, buried among bright starlight and dense dust, there appears to be a second ring, smaller, tighter, and easier to miss. Earlier observers do not immediately recognize it for what it is. In a crowded inner galaxy, many things can imitate one another. Spiral arms can overlap in projection. Dust can braid itself into misleading shapes. A compact ring seen at an angle can masquerade as part of a twisted inner pattern. For a time, that is more or less what happens. The feature is present, but it hides inside interpretation. Infrared observations begin to change that. Instruments sensitive to longer wavelengths can see dust patterns that visible light alone does not cleanly reveal. And in Andromeda, those patterns turn out to matter. Near the center, about half a kiloparsec from the nucleus, the inner dust structure resolves into something that does not sit comfortably inside a standard spiral explanation. It behaves too much like a ring. Once that realization takes hold, the entire geometry of the galaxy starts to shift. One unusual ring might be explained as an oddity. Two rings, especially at such different scales, suggest coordination, and coordination suggests cause. This is the point at which Andromeda stops looking merely irregular and starts to look interrupted. A spiral galaxy forms through long processes of rotation, collapse, feedback, and gradual change. Its pattern can be complex, but much of that complexity still belongs to internal evolution. Rings are different. Rings imply that material has been organized around a pulse, a wave, a compression moving outward from some disturbance. When astronomers see both the broad outer ring of star formation and the smaller inner dust ring, the image of Andromeda as a self-contained spiral begins to fail. The galaxy starts to resemble a surface across which something has passed. The analogy to ripples in water becomes difficult to resist, even though a galaxy is not a pond and gravity is not a splash. In water, a dropped stone sends rings outward because the surface carries the disturbance in expanding waves. In a galactic disk, an intruding mass can send density waves through stars, gas, and dust. The stars mostly pass each other without direct collision, but the collective gravitational shock can still rearrange the system. Gas clouds compress, dust lanes shift, star formation ignites where matter is squeezed. The wave travels long after the initial crossing. The visible rings are not the impact itself. They are the delayed expression of it. This interpretation gains force because of the way the rings are placed. The inner one sits near the core, where a simple spiral pattern might have seemed enough. The outer one lies farther out, broad and active, rich with young stars. Together they look less like decoration and more like a sequence. If a smaller galaxy plunges nearly head-on through Andromeda's disk, the resulting disturbance can launch multiple waves, leaving behind concentric traces at different radii. The idea is dramatic, but not careless. Astronomers model such encounters and find that direct collisions between galaxies can indeed produce ringed structures of this kind. The rings in Andromeda may be old shock signatures still visible long after the intruder has moved on. And then there is the candidate. Among Andromeda's companions, Messier 32 stands out because it is so close, so compact, and so awkwardly suggestive. In present-day images it appears as a bright elliptical blur near the larger galaxy, a satellite that might, at first glance, seem almost harmless beside the immense disk. But proximity changes suspicion. If Andromeda bears the marks of a head-on collision, then the small galaxy lingering nearby becomes difficult to ignore. Numerical simulations strengthen the link. When researchers test scenarios in which Messier 32 passes through Andromeda's disk, the models can reproduce key features of the observed rings. Not every detail falls into place with perfect certainty, but the resemblance is strong enough to change the tone of the story. The companion galaxy stops being scenery. It becomes a likely suspect. What makes this especially compelling is not only that the rings appear in the models, but that certain irregularities appear with them. The outer ring is not perfectly clean. There is a conspicuous gap where the structure seems interrupted, as though one ordered form has tangled with another. Simulations of a collision with Messier 32 can generate this kind of broken geometry, where an expanding ring intersects with pre-existing spiral structure. That matters because it moves the argument beyond vague resemblance. It suggests mechanism. The galaxy is not merely strange in a general way. It is strange in ways that a violent encounter can specifically explain. Even so, certainty remains elusive. Galaxies are old, layered systems, and any explanation that sounds too neat deserves caution. Messier 32 is close enough to implicate, and the ring structures support the case. But Andromeda is surrounded by many dwarf companions. Any past interaction leaves behind consequences that can overlap with others. A collision that happened hundreds of millions of years ago may not be the only event written into the disk. Dust can be displaced more than once. Gas can be compressed in successive episodes. One wave can cross the remnants of an earlier one. What appears as a clear signal may already be the blend of multiple histories. That uncertainty does not weaken the mystery. It deepens it. A galaxy with two rings is interesting. A galaxy whose rings may belong to a stack of old disturbances is far more difficult to read. The timing often placed on the likely collision, around 210 million years ago, adds another unsettling dimension. On cosmic timescales, that is recent. The ring structures are not relics from the ancient youth of the universe. They may be evidence of something that happened after complex stellar populations were already in place, after Andromeda had already matured into a massive system. This means the galaxy is not only shaped by deep primordial history, it is still being revised, even late in its life. A neighbouring spiral with a bright nucleus and majestic arms turns out to have suffered a direct encounter in the comparatively near past. The apparent stability of its silhouette becomes misleading. What seems ancient and settled may in fact be recovering. That possibility changes the way the inner regions are seen. The central bulge of Andromeda is so bright and crowded that it can feel almost static, like a permanent golden mass. But if the small inner dust ring is part of the same impact sequence as the larger outer ring, then even this crowded heart has not stood apart from disturbance. The wave reaches inward. The centre has been touched. A galaxy once imagined as a distant spiral hanging complete in the sky now starts to resemble a layered archive of collisions, where each smooth, bright zone may conceal a more troubled origin. And Hubble's role in this is subtle, but decisive. Hubble alone does not discover every piece of the puzzle, but its sharp portrait gives context to all of them. It shows where the stars are crowded, where the star-forming disk looks active, where asymmetries become hard to ignore, and how local patterns fit into the larger body of the galaxy. With Hubble's mosaic in mind, the rings no longer feel like isolated curiosities found in specialist data. They become part of Andromeda's visible personality. The galaxy looks elegant from afar, but the closer it is studied, the more its structure resembles evidence. This is why the image begins to feel almost forensic. Astronomers are no longer simply admiring Andromeda, they are reading it. The rings act like marks left behind by a passing force. The dust lanes behave like displaced material. The bright star-forming zones look less like spontaneous beauty and more like illuminated aftermath. The satellite nearby becomes a probable participant in an event whose moment has long vanished, but whose consequences remain spread across the disk. Every improvement in resolution sharpens the same impression. Andromeda is not a quiet spiral seen at a fortunate angle. It is a neighbouring giant whose calm exterior may be covering the residue of impact, compression, and recovery. And if that is true, then the galaxy is not simply being observed in the present. It is being caught in the long echo of something that struck it hard enough to leave rings in its body, dust rearranged near its centre, and a visible unease in structures once thought ordinary. The mystery is no longer whether Andromeda has been disturbed. The mystery is how many times, by whom, and what else in its shining disk still belongs to the same hidden chain of events. If the rings suggest that Andromeda has been struck, the southern side of the galaxy suggests that the blow was not small. For a long time, broad images of Andromeda encourage a kind of visual laziness. The galaxy looks balanced enough to be treated as a single object, a grand spiral with a bright centre and sweeping arms, slightly tilted, slightly dust-veiled, but fundamentally coherent. That impression does not survive closer study. As observations improve and the stellar populations are mapped in greater detail, Andromeda begins to separate into regions that do not seem to share the same history. The northern side appears comparatively composed. The southern side looks disturbed, stretched, and faintly haunted by structures that do not belong to any clean spiral design. It is here that the galaxy starts to show not just the marks of impact, but the residue of consumption. The need to examine this imbalance more carefully helps drive the extension of the Hubble work beyond the original survey area. The first major program covers a huge portion of Andromeda's star-forming disk, but not enough to settle the question of whether the galaxy's odd features are local or global. The later Southern Focus survey expands the map and adds roughly 90 million more stars to the resolved census. This matters not simply because the total count becomes more impressive. It matters because the newly covered region is exactly where Andromeda looks less settled. If the galaxy is carrying scars, the south appears to hold some of the deepest ones. What Hubble reveals most directly is not a dramatic single wound blazing across the image, but a landscape of subtle disorder. The stellar distribution on the southern side appears more ragged. Patterns that seem smooth elsewhere begin to fray. Regions of dust and light do not align with the symmetry expected from an undisturbed spiral. Yet one of the most important southern features is so faint that it does not dominate the famous mosaic at all. It must be brought out through deeper mapping and comparison with other observations. This is the giant southern stream, an immense trail of stars extending outward from the southern part of Andromeda and arcing into the halo. It reaches across roughly 150 kiloparsecs, which means it is not a local peculiarity. It is a structure on the scale of galactic history. A stellar stream is what remains when gravity tears a smaller galaxy apart. As the intruder falls into the larger system, tidal forces pull its stars loose and stretch them along its orbit. Over time, the original body dissolves, but the stars do not disappear. They continue moving along related paths, forming elongated rivers of light that preserve the memory of the encounter. The giant southern stream is one of those rivers. It is not bright in the way a star-forming ring is bright. It does not announce itself in blue clusters or in crowded golden glare. It is quieter than that, colder, more difficult to see, and for that reason perhaps more unsettling. It is less like a flash of recent violence and more like the lingering track of something already devoured. The stars in this stream are described as dissipationless, which is a technical way of saying they move without behaving like a colliding fluid. Gas clouds can shock, compress, radiate, and cool. A stream of stars does something different. The stars mostly pass one another as each follows gravity along its own path. They can be stretched, folded, and wrapped by the gravitational field of Andromeda, but they do not crash together and melt into one smooth, luminous band. This gives the stream a strange character. It is both coherent and fragile. It holds together as a visible structure across immense distance, yet it is really composed of separate stars tracing out the memory of a broken orbit. It is a fossil made of motion. Once this stream is taken seriously, the southern side of Andromeda stops looking merely untidy and starts looking like the site of a major event. The stream implies that at least one companion galaxy has been dismantled by Andromeda's gravity. More than that, its scale suggests a substantial interaction, not just the quiet absorption of a tiny dwarf. The halo, the stream, and certain metal-rich regions begin to hint at a past in which Andromeda has not simply been orbited by smaller neighbours, but has actively shredded them. The galaxy ceases to look like a passive spiral surrounded by satellites. It starts to look like a central body whose history is written in the remains of what it has pulled apart. This is where metallicity becomes important again. The giant southern stream, the inner halo, and Messier 32 all stand out as notably rich in heavier elements. That shared richness does not by itself prove a common origin, but it raises suspicion. Stars born in the same smaller galaxy before it was torn apart could carry similar chemical signatures. If the stream and certain other unusual components of Andromeda trace back to one larger intruder, then the southern disturbance is not just one more scar among many. It may be evidence of a major merger, one powerful enough to reshape the galaxy, seed new star formation, and leave behind surviving fragments in multiple places. The possibility is difficult to ignore because the southern side appears to remember more than the northern side does. This asymmetry is one of the most unnerving features of the whole system. Galaxies do not need to be perfectly symmetric, but large differences across opposite halves often imply past interactions. Something has happened to the south that either did not happen to the north, or did not leave equivalent traces there. It is as though the galaxy has a preferred direction of memory. One hemisphere preserves smoother order, the other carries debris, distortion, and a trail reaching far into the halo. This does not prove a single catastrophic event. It does, however, make a simple, calm history increasingly implausible. The imagination may be tempted to overstate what this means, so caution matters here. Andromeda has many dwarf companions, and galaxies evolve through repeated interactions across billions of years. The southern disturbance may be the combined result of more than one accretion event. Streams can overlap. Halos can preserve the remnants of several destroyed systems. A ring in the disk might come from one encounter, while a stream in the halo comes from another. The visible asymmetry could reflect timing as much as violence, with some features still coherent while others have already phase mixed into the background. These are real possibilities, but they do not make the evidence less dramatic. They make it harder to simplify. The South may be wounded not once, but repeatedly. Hubble's new portrait gives this complexity a sharper stage. By resolving stars across the disturbed regions, it becomes easier to compare populations, trace distributions, and ask whether certain groups belong together. A stream is no longer just a faint extra feature on top of a famous galaxy image. It becomes part of a broader question about how Andromeda assembled itself. Did it grow mainly through quiet long-term evolution, with occasional minor disruptions? Or has it repeatedly fed on neighbours large enough to leave chemistry, streams, rings, and uneven stellar ages behind them? The southern side seems to lean toward the darker answer. It suggests that Andromeda's present form may be inseparable from what it has absorbed. This transforms the emotional character of the galaxy. The outer ring already hints at impact. The inner ring suggests deeper penetration into the disk, but the giant southern stream implies something more intimate and more final. A collision can disturb. A stream testifies to destruction. Somewhere in Andromeda's past, another stellar system may have crossed too close, been trapped by gravity, and slowly unravelled into a long, pale trail. That trail now hangs at the edge of one of the most famous galaxies in the sky, too faint for casual attention, yet too large to dismiss. It is the kind of feature that changes the meaning of the whole object around it. The bright spiral ceases to be only a neighbouring island of stars. It becomes a place where smaller islands have broken apart. And once that possibility is accepted, the South takes on a new role in the story. It is no longer simply the messier half of the image. It is the side where Andromeda's appetite becomes visible. The more the mosaic expands, the less the galaxy resembles a completed spiral resting in balance. It begins to look like a system still carrying the dispersed remains of encounters that have not fully settled into the background. The southern wound does not close quickly. It stretches outward in stars, in chemical clues, and in asymmetry, inviting a more unsettling thought. The violence recorded in the rings may not be the whole story at all. They may only be the brighter, easier to see surface of a much larger process by which Andromeda has been built, disturbed, and perhaps enlarged through the slow dismantling of its companions. Among the many companions surrounding Andromeda, one object keeps drawing attention for reasons that seem at first almost unfair. Messier 32 is small beside the galaxy it accompanies, bright but compact, easy to overlook in the splendour of the larger spiral. In wide images it appears as a soft, rounded concentration of stars hanging close to Andromeda's disk, almost like a note in the margin of a far grander composition. If Andromeda is the main event, Messier 32 can seem like a footnote. Yet in the growing effort to explain Andromeda's strange rings, its disturbed southern halo, and its uneven stellar history, this small satellite begins to take on an altogether different character. It starts to look less like a nearby dwarf and more like a survivor. The suspicion grows slowly because Messier 32 is a peculiar object even before it is woven into the larger mystery. It is unusually compact for a galaxy of its kind. Its stars are crowded into a tighter body than astronomers might expect from a normal small elliptical companion. It also lies uncomfortably close to Andromeda, close enough that any history of strong interaction becomes plausible. Nearness alone proves little. Satellites can orbit giant galaxies for long periods without producing an especially dramatic visible signature. But once Andromeda's rings, streams, and asymmetries are taken seriously, the small galaxy's position begins to feel less innocent. It is too near to ignore and too strange to leave uninterpreted. The first role assigned to Messier 32 is the simpler one. It is treated as the likely intruder responsible for the ring structures in Andromeda's disk, the small galaxy that may have plunged through the larger system and launched the waves that still shape the star-forming ring and the inner dust ring. That explanation already gives it a more active place in the story, but it does not stop there. As astronomers try to connect more of Andromeda's anomalies into one coherent history, a more unsettling possibility emerges. Messier 32 may not merely be a small satellite that once struck the disk. It may be the stripped-down core of a much larger galaxy, one that Andromeda almost completely consumed. This is where the object starts to resemble a ghost. If the idea is correct, then the visible galaxy called Messier 32 is not the full intruder at all. It is what remains after tides, compression, and prolonged interaction tear away most of the original system. The outer stars are lost first, peeled off into streams and halos. Gas is drawn into Andromeda's deeper gravitational field. Star formation may be triggered across the larger galaxy as fresh material is mixed and compressed. What survives is the densest central piece, compact enough to resist total destruction, bright enough to remain visible, and altered enough to look oddly incomplete. The little companion seen today would then be less a satellite in the usual sense than a remnant, the bare centre of a galaxy whose former size is now remembered only indirectly. This possibility gathers strength from chemistry as much as from shape. Messier 32, the giant southern stream, and metal-rich components of Andromeda's inner halo appear to share a notable richness in heavier elements. That shared chemical character does not prove they come from the same system, but it makes the connection tempting. A larger, metal-rich progenitor falling into Andromeda could supply stars to the stream, contribute to the halo, and leave behind a dense core still visible as Messier 32. In that picture, several of Andromeda's strangest features stop being isolated curiosities and begin to fit the same narrative of capture and dismantling. There is also the question of mass. Researchers modelling Andromeda's history have suggested that the ancestor of Messier 32 may once have been enormous by satellite standards, with a mass of roughly many tens of billions of suns. That scale changes everything. A body of that size would not be a minor ornament orbiting harmlessly nearby. It would be a major participant in Andromeda's evolution, large enough to distort the disk, stir the halo, and seed burst of star formation. If such a galaxy merged with Andromeda between about 5 billion and 2 billion years ago, then many of the larger galaxy's present oddities may not be side effects at all. They may be consequences. What makes the idea especially compelling is that it helps explain why Messier 32 looks so compressed today. If a larger galaxy loses its outer parts to tidal stripping, what remains becomes denser in appearance almost by definition. The sprawling original system is gone. Only the gravitationally deepest core survives. That core may then seem oddly overcompact for its size, because its visible dimensions no longer reflect the galaxy it once was. It is the residue of a much bigger thing, cut down to its hardest centre. In that sense, Messier 32 would not merely be a companion galaxy with unusual properties, it would be a ruin. The black hole at its centre adds another layer to the puzzle. Estimates place the mass of that central black hole at only a few million times the mass of the Sun. In a normal galaxy, the black hole and the central bulge often hint at one another's scale. If the surviving core of Messier 32 contains a relatively modest black hole, that suggests the original bulge may not have been enormous, even if the full galaxy was far larger overall. This detail matters because it offers a way to understand why the remnant survives outside Andromeda's exact centre, rather than vanishing fully into it. A galaxy with a small dense bulge embedded in a much larger outer body might be torn apart without its core sinking all the way into the nucleus of the host. The central remnant could survive in the outskirts, orphaned from most of what once belonged to it. This is not a complete proof. Galaxy mergers are messy, and the pathways by which remnants survive can vary widely. But the idea has an internal logic that is difficult to dismiss. A once substantial intruder approaches Andromeda. Its gas is stripped or absorbed. Its stars are stretched into streams and folded into the halo. Its gravitational passage perturbs the disk. New stars ignite in Andromeda from redistributed material. Over time, only the compact centre of the intruder remains identifiable as a separate body. The original galaxy is gone, yet not gone. It survives partly in the giant stream, partly in chemical fingerprints, partly in younger populations born from stirred gas, and partly in the compact object still orbiting nearby. The result is both elegant and disturbing. One small galaxy may be the visible remainder of a much larger disappearance. The deeper unease comes from how this changes Andromeda's identity. If Messier 32 truly is a remnant core, then Andromeda is not merely a galaxy that happens to have a close neighbour. It is a galaxy still carrying the partially digested remains of an older merger in plain sight. The neighbour becomes evidence. The relationship between the two systems is no longer one of simple companionship. It becomes a history of encounter, stripping, survival, and incomplete absorption. What looks like proximity in the present may actually be the last stage of an ancient destruction. This also affects how the eye reads the famous Hubble portrait. Once the possibility is entertained, every view of Messier 32 gains an added tension. The bright compact blur beside Andromeda's disk is no longer a minor satellite against a grand background. It is a potential witness. It may hold in its compressed structure a record of what Andromeda does to galaxies that come too close. The larger spiral begins to seem less like a calm neighbour and more like an archive of accretion, where the evidence of past encounters remains visible not only in rings and streams, but in surviving fragments that have not yet fully disappeared, and still uncertainty remains. Messier 32 may indeed be the stripped core of a larger progenitor, or it may be only one player in a more complicated sequence of mergers and satellite interactions. Other companions may have contributed to the halo, to the streams, to the unevenness of the disk. The true history may involve several intrusions layered over billions of years, but that uncertainty does not weaken the object's eerie role, even if it is only part of the answer. Messier 32 represents a possibility that cannot easily be forgotten once seen. Something small and bright beside Andromeda may be all that remains of something much larger, a core left intact after the rest has been scattered across another galaxy. The companion then ceases to look ordinary. It becomes a ghost that still orbits the body that stripped it down, visible enough to be recognized, altered enough to suggest how much has already been lost. By the time Andromeda's rings, streams, and suspect companion have all entered the same conversation, another anomaly begins to feel less isolated than it once did. It concerns not where stars are, but when they seem to have formed. In a large spiral galaxy, astronomers expect a rough layering of ages. The central bulge and much of the halo usually contain very old stars, ancient populations left from the early construction of the galaxy. The thin disk tends to host younger stars, especially in regions where gas still feeds ongoing star formation. This is not a rigid rule, and no galaxy is truly simple, but the basic expectation is that a mature spiral should show some broad separation between old inner populations and younger outer activity. Andromeda does not fully cooperate. It contains an enormous population of stars of intermediate age, too many to fit neatly into the calm picture of gradual evolution. The galaxy seems to have had a second life. This is one of the most quietly disruptive clues in the entire story, because it does not announce itself in a striking image the way a ring or stream does. It emerges from patient stellar archaeology. Astronomers study the colours and brightnesses of resolved stars, compare them with models of stellar evolution, and reconstruct when large groups of those stars must have formed. Hubble's ability to resolve so many individual stars is crucial here. Without that power, much of Andromeda's light would remain blended into a broad glow, and its age structure would be harder to separate. But with enough stars individually measured, the galaxy begins to reveal something unexpected. A vast number do not belong exclusively to the oldest ancient component, nor to the youngest star-forming regions. They fall in between. They suggest that Andromeda experienced a major episode of starbirth well after its earliest construction. That alone would be interesting. In the context of everything else, it becomes more. If Andromeda underwent a substantial burst of star formation between roughly a few billion and several billion years ago, then the event may connect directly to the same merger history implied by the southern stream and the possible destruction of a larger progenitor, linked to Messier 32. A major merger does not simply rearrange stars already present. It can also deliver gas, destabilize the gas already in the host galaxy, and trigger new waves of starbirth on a grand scale. In that case, the intermediate age stars are not just another separate puzzle. They are one more consequence of impact. They may be the living residue of a collision, born after the disturbance, carrying it forward in their very existence. This changes the way Andromeda's stellar population is read. The galaxy no longer appears as a structure that forms early, settles into order, and then merely accumulates minor damage. It begins to look like a system that has been repeatedly revised, even in relatively late epochs. A burst of star formation on that scale implies not a quiet continuation of the same old rhythm, but an interruption strong enough to alter the age profile of the whole galaxy. Andromeda may not simply be older than it looks in places, it may be younger than it should be in others. The contradiction is exactly what makes it compelling. A neighbouring giant that seems ancient at a glance turns out to contain evidence of renewal. But renewal arrived not as peace, rather as aftermath. The language of a second wind is useful here because it captures both the surprise and the uncertainty. The galaxy appears to have been stirred back into vigorous star formation long after its earliest epochs, yet that renewed activity is not spread with comforting symmetry. It is layered unevenly across a system already carrying signs of disruption. The new stars are not evidence that everything is healthy and orderly. They may instead be evidence that something tore through the old arrangement and forced the galaxy into a fresh cycle. In human terms, a second wind sounds energizing. In galactic terms, it may follow trauma. This possibility sharpens the significance of Andromeda's current appearance. The bright young stars in the outer ring already hint at recent disturbance. The intermediate age stars point to something older and perhaps even larger. Together they imply that Andromeda's history may contain multiple episodes of violent revision, each leaving behind a different population. Some stars record the ancient assembly of the galaxy itself. Others may have formed during a major merger with a substantial intruder. Still others trace more recent waves in the disk, perhaps linked to later interactions. The galaxy becomes stratified not only in space but in time. It is less a single clean structure than a layered archive in which different eras remain partly visible at once. This is also where comparison with the Milky Way becomes more revealing and more uncomfortable. The two galaxies are often treated as broad equals, the largest members of the local group, comparable spirals heading toward an uncertain future. But Andromeda's unusual abundance of intermediate age stars suggests that its recent history may have been more violent than that of the Milky Way. The home galaxy shows signs of mergers too, both past and ongoing, but not in quite the same overwhelming form. If Andromeda truly received a massive gas-rich intruder a few billion years ago, and if that event created a fifth or so of the stars now present in the larger system, then Andromeda is not simply a bigger mirror of the Milky Way. It is a more deeply disturbed cousin. The implications extend beyond appearance. A major burst of star formation affects chemistry, dynamics, and future evolution. Young massive stars enrich surrounding gas with heavier elements when they die. Their radiation and stellar winds alter the interstellar medium. Supernova explosions stir and heat the disk. Whole regions of the galaxy can be changed by the cumulative effects of one merger-driven episode of renewed starbirth. In that sense, the intermediate age population is not just a demographic oddity. It may mark the period when Andromeda's modern personality took shape. Some of its present brightness, some of its chemical structure, and perhaps even part of its current instability may trace back to that one rejuvenating disturbance. Yet the evidence remains frustratingly indirect, which is part of what preserves the mystery. No observer sees the merger occur, no simple boundary marks which stars belong to which chapter. Astronomers infer histories from ages, motions, metallicities, and distributions. The more these clues align, the stronger the narrative becomes. But the galaxy does not offer a labelled timeline. It offers overlapping populations and strange consistencies that ask to be interpreted. The intermediate age stars do not come with a certificate stating that they were born in the wake of a major collision. They simply gather in numbers too large to ignore and ages too suggestive to dismiss. They ask the same unsettling question the rings and stream already ask in different forms. What happened to Andromeda after it should have already settled down? There is also a deeper conceptual shift hidden in this evidence. Galaxies are often imagined as ancient machines running on very long cycles, too slow for sudden change to matter. Andromeda resists that image. The age spread of its stars suggests a system capable of being shaken into new activity long after its foundations are laid. It is not frozen by maturity. It remains vulnerable to outside influence. A single merger can reroute its development, create new populations, restructure regions of the disk, and leave signatures that persist billions of years later. The galaxy is vast, but not immune. Its scale does not protect it from revision. It only makes the revision grander and harder to fully trace. This is one reason Hubble's role feels so profound. The telescope does not merely show Andromeda in sharper focus. It helps dissolve the illusion that a galaxy is one thing at one age in one stable form. It reveals a place where old and younger stars coexist in patterns that point toward interruption. Once the intermediate age population comes into view as a real problem to explain, the famous image of Andromeda changes yet again. The bright nucleus, the spiral pattern, the blue ring, the uneven south, the close companion, all of it starts to sit inside a deeper time structure. The galaxy is not only spatially complex, it is temporally dissonant. Different parts seem to belong to different eras, and some of those eras may have been triggered by violence. And perhaps that is the most striking consequence of this clue. The stars themselves become witnesses, not merely points of light, but records of when the galaxy last changed its character in a major way. Some belong to the earliest Andromeda. Some may belong to the Andromeda that exists after a large intruder is broken and absorbed. Some are even younger, tracing later waves of star formation still visible in the disk. Seen this way, the galaxy no longer resembles a single story told from beginning to end. It resembles a book rewritten in several hands, with older chapters preserved underneath newer ones. The intermediate age stars are among the clearest signs that the rewriting was substantial, and once that is understood, the question becomes harder to avoid. If Andromeda has already had one second life, perhaps driven by merger and upheaval, then how many parts of its present form are really aftermath rather than origin? Once Andromeda begins to look like a galaxy built not only by its own gravity, but by repeated encounters with smaller companions, the view around it changes as well. The great spiral no longer stands alone in the mind as a finished object. It stands at the center of a system of lesser galaxies, dim satellites moving through its outskirts, each one a possible witness, victim, or future participant in the shaping of the whole. Around Andromeda there are several dozen known dwarf companions. Some are diffuse and ghostly. Some are compact and bright. Some move on paths that may keep them at a distance for long stretches of time. Others pass close enough to stir suspicion. Taken one by one, they can seem like minor details orbiting a major galaxy. Taken together, they create a different impression. They make Andromeda look less like a solitary spiral and more like the crowded center of an ongoing gravitational conversation. This broader setting matters because a galaxy's visible body rarely tells the whole story of its growth. Large galaxies are assembled over time, not only through the slow condensation of gas and the steady birth of stars, but also through accretion, the capture and absorption of smaller systems. Some of those systems are swallowed almost completely. Some survive as distorted companions. Some leave behind streams, shells, or faint over densities in the halo. Others may pass through the disk, excite waves, and continue onward in altered form. The process is not clean. It leaves partial signatures, overlapping signatures, signatures that fade at different rates. Once Hubble's portrait reveals Andromeda in such fine detail, those signatures begin to matter more because the galaxy stops looking smooth enough to hide them. The trouble is that too many clues can make the mystery harder rather than easier. If only one companion had ever interacted strongly with Andromeda, the narrative might settle into something satisfying. One intruder, one collision, one ring, one stream, one surviving remnant. But the galaxy's environment refuses that simplicity. With dozens of dwarf galaxies around it, Andromeda may have experienced many encounters over billions of years, not all of them equally dramatic, not all of them fully erased. Each one has the potential to leave behind some trace in the disk, halo, or satellite system. The result may be a galaxy whose present appearance is not the product of one decisive event, but the layered sum of many smaller ones plus a few major shocks. That possibility changes the way every anomaly is read. Nothing stands fully alone anymore. This is especially important in the halo, the vast spherical region of stars, dark matter, and sparse globular clusters surrounding the main disk. Halos often preserve the long memory of mergers because debris can remain coherent there for immense spans of time. A stellar stream can wrap around a galaxy like a pale thread. A shell of stars can mark where an intruder plunged inward and then slowed. Metal-rich pockets can betray a swallowed companion whose chemical history differed from the host. In Andromeda, the halo appears richly structured, more populated with tidal debris than might be expected from a galaxy with a quiet recent past. The giant southern stream is only the most dramatic example. There are other clumps, arcs, and substructures, some faint, some uncertain, together suggesting that Andromeda's outskirts are not a smooth envelope but a field of remnants. This is where the mystery deepens in a very specific way. A single major merger can explain many things, but not everything. A ring in the disk may trace one encounter. A stream in the halo may trace another, unless both can be convincingly tied to the same lost intruder. A compact satellite may be the remnant core of a larger destroyed galaxy, but other satellites still remain in orbit, each with its own chance of having crossed paths more violently in the past. The southern asymmetry may be the fresh memory of one event, while subtle disturbances elsewhere may be the faded memory of several more. The galaxy begins to resemble a palimpsest, a surface written on repeatedly, where new marks do not fully erase older ones. That makes interpretation difficult, but it also makes Andromeda feel alive in a way broad classifications cannot capture. The satellites themselves vary in character enough to complicate the picture further. Some dwarf spheroidal galaxies around Andromeda appear faint and extended, shaped less by active star formation than by stripping and aging. Others retain denser stellar bodies. Some may once have had more gas and more stars before Andromeda's influence reduced them. This matters because present appearance can be misleading. A small galaxy seen today may not be small in the same sense it once was. A companion may already have lost a large fraction of its original mass to tides, just as Messier 32 may be only the compact residue of something larger. If that is true for more than one satellite, then the current family of Andromeda understates the scale of its own past interactions. The quiet companions visible now may be survivors after damage, not untouched bystanders. There is also the question of orbital alignment, a topic that has drawn attention because some of Andromeda's dwarf galaxies appear to occupy preferred planes or shared patterns of motion. Such arrangements are difficult to interpret with confidence, and the evidence is still debated. But the very possibility is provocative. If a subset of satellites is arranged in a correlated structure, that may hint at common origin, shared in fall, or some deeper dynamical history tied to Andromeda's assembly. Instead of being captured at random from all directions, some companions may have arrived together or been redistributed by major past encounters. The implication is subtle, but powerful. The satellite system may itself carry fossil geometry, a larger scale memory of how Andromeda grows. When this wider environment is viewed alongside Hubble's star-by-star mapping, the galaxy's beauty starts to feel almost misleading. The brilliant disk and crowded nucleus dominate attention, but the true drama may be distributed far outside the brightest regions, streams stretching into the halo, dwarf galaxies altered by tides, chemical signatures hinting at lost progenitors, and asymmetric structures in the outskirts all suggest that Andromeda is not merely a spiral surrounded by ornaments. It is a giant body continually negotiating with a population of lesser ones. Some are being captured, some are being shredded, some may already be half dissolved into the halo, some may be waiting for future close passages that will add yet another layer to the record. This possibility introduces a quieter but more unsettling form of speculation. Perhaps Andromeda's current disturbed appearance is not unusual for a galaxy of its kind. Perhaps large spiral galaxies commonly carry this much unresolved debris and this many overlapping merger signatures, only hidden from easy view unless a telescope like Hubble resolves enough stars to expose them. If so, Andromeda is not strange because it is exceptionally violent. It is strange because it is close enough to reveal how untidy galactic life really is. The textbook spiral may then be more of a distant illusion than a stable category. Order exists, but it rides atop a long history of assimilation. Andromeda, however, still seems to stand out even within that broader thought. Its disturbed southern region, its ring structures, its suspected major merger, and its remarkable intermediate age population all suggest a system that has not merely accreted minor dwarfs in the background. It may have experienced substantial interactions late enough and large enough to alter its whole internal balance. The satellite population reinforces that suspicion because it offers too many avenues by which such alteration could occur. Every companion around Andromeda becomes a possible chapter, and the sheer number of chapters implies that the visible galaxy may be a summary rather than a beginning. This is also where humility returns to the science. Better images do not automatically produce a final map of cause and effect. They create a richer field of evidence, but evidence can multiply faster than interpretation. With Andromeda, the more detailed the picture becomes, the more plausible histories compete. One can imagine a dominant ancient merger with one large progenitor, followed by a sequence of smaller accretions that decorate the halo and disturb the disk. One can imagine multiple moderate mergers whose signatures now overlap so thoroughly that they mimic the effects of a single larger event. One can imagine present-day satellites as the sparse survivors of a once more populous system already thinned by capture and disruption. None of these possibilities floats free of observation. Each is anchored in some visible or measurable fact, yet none closes the case. That may be why Hubble's portrait has such a strange effect on Andromeda's image in the mind. It does not isolate the galaxy from its surroundings. It does the opposite. It makes the disk feel porous to history, open to the influence of companions near and far. The eye begins to move outward from the central spiral and sees not empty space, but a complicated neighbourhood full of potential intruders and remnants. The galaxy's past then stops looking like a sequence of internal developments and starts looking like a series of encounters, some obvious, some almost invisible, all carried forward in stars that still orbit where older galaxies once held together. And so Andromeda's many satellites do not reduce the mystery by offering many suspects. They deepen it by making the crime scene larger. Every dwarf companion around the galaxy raises the same quiet possibility. At some earlier time, it may have been closer, heavier, brighter, richer in gas, less damaged, and more capable of changing the host it now circles. The present arrangement may therefore be only the latest still frame in a long-moving history of approach, stripping, disruption, and survival. Andromeda shines at the center of that history, but it no longer seems self-made. It seems assembled, revised, and still surrounded by the smaller bodies from which future clues may yet emerge. For much of the modern imagination, the most dramatic fact about Andromeda is not what happened inside it long ago, but what may happen between it and the Milky Way far in the future. The idea has become almost iconic: two giant spiral galaxies, the two dominant members of the local group, falling toward one another across intergalactic darkness, destined to merge into a single larger system after several billion years. It is a story large enough to feel mythical and distant enough to feel harmless. By the time such an event unfolds, Earth will be unimaginably altered or long gone, the Sun itself approaching the later stages of its life. The collision is therefore easy to treat as a spectacle of deep time, something grand but abstract. Yet once Hubble's new portrait of Andromeda begins to expose how disturbed the neighbouring galaxy already is, the future encounter takes on a different tone. The issue is no longer simply whether two textbook spirals will one day merge. The issue is whether the Milky Way may one day meet a galaxy whose current form is already the result of repeated violence, and whether even that meeting is less certain than it first appeared. The older version of the future is stark and compelling. Measurements of Andromeda's motion indicate that it is moving toward the Milky Way at roughly 110 kilometers per second, along the line between the two galaxies. For many years, this inward motion encourages the expectation of an eventual direct merger. Computer models show the two spirals approaching, their disks distorting, tidal tails stretching outward, gas clouds compressing, and over time a new, larger galaxy emerging from the long gravitational struggle. The nickname often given to this imagined descendant is playful, but the underlying physics is not. Galaxies can and do merge. When they do, stars are flung onto new orbits, central black holes may later coalesce, and the ordered shapes of the original disks can be lost. The thought that the Milky Way and Andromeda are headed towards such an end has long seemed plausible enough to count almost as accepted destiny. Yet destiny in astronomy is rarely as simple as a single speed measurement. To predict whether two galaxies will actually collide, astronomers need not only the rate at which they approach one another, but also their sideways motion, their masses, the distribution of dark matter around them, and the influence of other major members of the local group. Even slight changes in these ingredients can alter the result over billions of years. A system can pass through a near encounter instead of a direct merger. It can merge later than expected. It can be perturbed by another galaxy and shifted onto a different path. Once the problem is viewed in full, certainty begins to dissolve. This is where Andromeda's new Hubble-based measurements become important in a way that reaches beyond the galaxy itself. The same observational effort that resolves stars across the disk and helps reconstruct Andromeda's past also improves the distance scale and the models used to understand the local group. Cepheid variable stars within Andromeda, measured more precisely through Hubble's surveys, refine estimates of where Andromeda sits in space and how the wider local system is arranged. Those refinements, when combined with data on the motions of other nearby galaxies, especially the Large Magellanic Cloud, begin to alter the future picture. The result is not a comforting cancellation of danger, because danger is hardly the point on these timescales. The result is something more intriguing. The famous collision may not be inevitable at all. Recent modelling suggests that the probability of a full merger between the Milky Way and Andromeda within the next 10 billion years may be closer to a coin toss than to certainty. That is a remarkable shift in tone. A story once told as the settled future of the local group becomes an open question. The two galaxies may still collide. They may pass close enough to transform one another severely. But the outcome is no longer cleanly fixed. Even after all the data gathered across decades, the fate of the Milky Way remains partially unresolved. That uncertainty feels especially fitting once one has seen how difficult it is to reconstruct Andromeda's own history. If the past of one galaxy is layered and ambiguous, perhaps the future of two galaxies should be expected to resist simplicity as well. The possibility of a near miss is not dull. In some ways it is stranger than a straightforward collision. A close passage between the Milky Way and Andromeda could still tear long tidal structures from both galaxies, displace stars, distort disks, and reshape the local gravitational environment without immediately producing a final merged remnant. The galaxies might approach, deform one another, drift apart on altered trajectories, and only later settle into another encounter. Or another body in the local group could influence the sequence. The Large Magellanic Cloud, though far smaller than either giant spiral, carries enough mass to matter dynamically. Its motion can slightly shift the centre of mass of the Milky Way system and complicate the long-term dance. Over billions of years, small differences accumulate. The future becomes less a single impact and more a choreography sensitive to details. And this is where Andromeda's present condition begins to matter emotionally, if not strictly mathematically. A calm, undisturbed neighbouring spiral approaching the Milky Way would already be enough to inspire cosmic unease. But Hubble's portrait does not show a pristine spiral. It shows a galaxy with a turbulent disk, a lopsided recent history, streams of stellar debris, evidence of past mergers, and perhaps a surviving remnant core from a galaxy it largely consumed. The object moving through the dark toward the Milky Way may therefore not be thought of as a neat galactic twin. It may be better understood as a giant system already shaped by accretion and collision. The meeting, if it comes, would not be the first time Andromeda has transformed another galaxy. It would only be the largest example in the neighbourhood. That thought risks exaggeration if left unchecked. So restraint is important. Galaxies do not behave like predators in a human sense. Their mergers are not acts of intent. They are consequences of gravity operating across immense scales. Andromeda does not advance toward the Milky Way with purpose. It moves because mass shapes motion. Yet the language of appetite lingers because the evidence of absorption is hard to overlook. The southern stream, the suspected remains of a larger progenitor, the intermediate-age stars likely born from merger-triggered gas. All of it suggests that Andromeda has already grown through the dismantling of others. In that context, the future encounter with the Milky Way acquires a subtle asymmetry. It is no longer just two galaxies colliding. It is one galaxy with a visible record of galactic assimilation approaching another whose own history, while complex, seems less visibly dominated by late major disruption. Still, the true future may be gentler than the dramatic image suggests. Even in a direct merger, the chance of individual stars colliding is extraordinarily small, because the distances between stars are so vast compared with their sizes. Solar systems are more likely to be perturbed gravitationally than physically struck. The night sky, if any observers existed to see the changes over millions of years, would become more crowded, more distorted, more brilliant in places, but not necessarily more violent at the local stellar level than intuition might expect. The real transformation would unfold through orbital rearrangement, gas compression, bursts of star formation, and the slow loss of the graceful disk shapes both galaxies currently possess. The danger is structural, not cinematic, yet in some ways that makes it more haunting. A galaxy can be changed beyond recognition without most of its stars ever touching. What remains most striking is how Hubble's study of Andromeda contributes to this uncertainty rather than eliminating it. One might imagine that a better portrait of the neighbouring galaxy would sharpen the prediction and lock the future into clearer focus. Instead, The improved data reveal a more complicated local group and a more conditional outcome. This is deeply characteristic of Andromeda as a whole. The better it is seen, the less simple it becomes. Its past turns out to be layered. Its present turns out to be structurally uneasy. Its future with the Milky Way turns out to be unresolved. Clarity keeps producing ambiguity of a higher order. The deeper mystery, then, is not merely whether the Milky Way and Andromeda will collide. It is what kind of future can be forecast in a gravitational system where history matters so much. Andromeda's mass distribution has been shaped by mergers. The Milky Way's motion is influenced by its own companions. Dark matter halos overlap and interact. Smaller galaxies tug at larger ones over immense time spans. Every one of these factors grows more significant the farther ahead the prediction reaches. The local group is not a simple pair of objects heading toward a fixed point. It is a living gravitational network whose future depends on conditions still being measured. And so the famous question remains suspended in a more interesting form. Will Andromeda collide with the Milky Way? Perhaps. Will the two galaxies transform one another even if the path is not a perfect direct hit? Very likely. Will the serene patterns now seen in the night sky survive unchanged across the next several billion years? Almost certainly not. But the exact script is still unwritten. That uncertainty becomes even more powerful once Andromeda is no longer imagined as a distant decorative spiral, but as a nearby giant with a history of impacts already recorded in its stars. The galaxy approaching from 2.5 million light-years away is not a blank future object. It is a system with memory. And whether it eventually merges with the Milky Way or merely brushes past and reshapes the entire local stage, its next great chapter may already be moving toward us through the dark, still too far for the consequences to be felt, but close enough for the possibility to remain impossible to forget. What Hubble finally gives Andromeda is not an ending, but a surface dense enough to keep yielding deeper questions. That may be the most surprising outcome of the whole effort. A 10-year mosaic built from more than 1,000 orbits might seem like the sort of project that closes a chapter. It sounds definitive. It sounds like the long-awaited portrait that turns a neighboring galaxy into a known object. Instead, the opposite happens. The image becomes so detailed, so crowded with resolved stars and uneven structures, that it starts behaving less like a conclusion and more like the opening of an archive. Every bright cluster, every dust lane, every asymmetry, every suspicious concentration of stars becomes something to test. The grand mosaic is not the last word on Andromeda. It is a map of unsolved problems. This is partly because Hubble is unusually good at revealing the kind of evidence that becomes more valuable over time. A blurred image can be admired and then set aside. A star-by-star survey can be revisited again and again as methods improve. Astronomers can compare one region with another, separate stellar populations more carefully, refine age estimates, examine metallicity patterns, and ask whether structures that first appear disconnected are really fragments of one older event. The mosaic does not change, but the questions asked of it do. In that sense, Hubble turns Andromeda into a long-term laboratory. The neighbouring galaxy becomes a standing experiment in galactic memory, with new interpretations waiting inside data already gathered. The scale of the portrait makes this even more striking, spread out at full size. The image contains enough detail to fill dozens upon dozens of ultra-high-definition screens. That fact is often presented as a measure of spectacle, but it also hints at something deeper. The human eye cannot take the whole thing in at once. Understanding must move across it region by region. The galaxy refuses to become simple because it cannot be absorbed in one glance. It must be explored almost like terrain. There is always another dense field of stars, another faint structure near the edge of the disk, Another transition between populations that might mean more than it first seems to mean. The map invites wandering, and wandering invites discovery. This is why Hubble's discovery inside Andromeda is not one object or one event. It is the realization that the inside of the galaxy is far less unified than the famous spiral outline suggests. The portrait reveals a system that can no longer be treated as a single calm form. Instead, it appears as a superposition of different times, different disturbances, and different kinds of matter arranged into one visible body. The nucleus blazes with crowding so intense that separate stars dissolve into golden density. The disk carries rings that look like shock signatures. The southern side appears more disturbed than the northern side. The halo preserves trails of lost companions. The satellite system around the galaxy hints that the visible body may only be the largest surviving component of a much messier assembly history. Hubble does not discover a secret chamber hidden at Andromeda's core. It discovers that the whole galaxy is internally full of consequences, and once that realization takes hold, other observatories begin to matter in a new way. Hubble's visible and near-ultraviolet view is powerful, but it does not cover every kind of evidence. Infrared observatories help trace the colder dust and stars partly veiled behind obscuring lanes. X-ray observatories reveal energetic binaries, hot gas, and activity close to the central black hole. Radio instruments show the distribution and motion of gas that may feed future star formation or preserve the kinematic memory of older disturbances. Each observatory adds a layer, and with Hubble's mosaic as a structural framework, those layers can be placed into a richer context. A stream of stars in one map, a dust feature in another, an X-ray source near the center, a gas asymmetry in radio data. Together they start to act less like isolated findings and more like interlocking clues. The center of Andromeda is an especially powerful example of this unfinished depth. Hidden inside that crowded brilliance is a supermassive black hole, smaller than the one in the most extreme active galaxies, but massive enough to shape the orbits of stars near the nucleus. Chandra's more recent X-ray observations sharpen the view of this region and add another dimension to the portrait. They do not transform Andromeda into a blazing quasar. Its central black hole is comparatively subdued. Yet the fact that even this apparently quiet nucleus continues to be re-examined shows how incomplete the story remains. A galaxy can be calm by the standards of violent active nuclei and still conceal a complicated central history. The black hole may be quiet now, but the stars packed around it, the dust structures nearby, and the broader merger history of the galaxy raise lingering questions about how often that calm has been interrupted in the past. Other future observations may deepen the puzzle rather than resolve it. Infrared studies with newer instruments may separate stellar populations in dusty regions even more clearly, and reveal whether some features now treated as coherent are actually layered. Precise motion measurements may show which stars truly belong to streams, rings, or disturbed disk components, and which merely overlap them from our line of sight. Deeper surveys of faint halo structures may uncover additional debris from mergers not yet recognized. There may be more streams, more shells, more chemical gradients, more surviving remnants. And if that happens, the story of Andromeda may become simultaneously clearer in detail and less tidy in overall shape. This possibility is not a flaw in the science. It is one of the reasons the galaxy matters so much. Andromeda is close enough to study at the level of individual stars, yet large enough to behave like a true giant spiral with a long and complex history. It occupies a rare position in astronomy. More distant galaxies can show dramatic forms, but not with the same star-by-star intimacy. The Milky Way can be studied in extraordinary local detail, but from inside it the global structure is harder to read. Andromeda sits between those limitations. It is external enough to be seen as a whole and near enough to be dissected. That makes it one of the best places to test how galaxies remember what happened to them. Hubble's portrait therefore begins to feel less like a beautiful image than like a threshold. Before it, Andromeda is already famous. After it, the galaxy becomes legible in a more demanding sense. The eye can no longer rest on the spiral and move on. It is drawn inward to the unresolved evidence written through the disk and halo. The question stops being what Andromeda looks like and becomes what sequence of events can plausibly produce what it looks like now. That is a much harder question, and it is still open. There is also a quiet irony in the timing. The galaxy that once helped reveal that the universe extends beyond the Milky Way now helps reveal that even a single neighbouring galaxy is too complex to summarise quickly. Andromeda first enlarged the universe by proving that there are other galaxies. Hubble's modern mosaic enlarges it again in a different way, by showing how much history can be hidden inside one of them. The lesson is no longer about counting galaxies. It is about understanding that each one may contain layers of past worlds, past collisions, past bursts of star formation, and past rearrangements still visible if the data become sharp enough. This is why the shock inside Andromeda is not a single spectacular object waiting near the nucleus. It is the accumulation of evidence that the galaxy's present form is the visible residue of a long unsettled past. The shock is that improved vision does not reveal peace. It reveals structure that has been bent, stirred, interrupted, and rewritten. Hubble's great discovery is therefore not simply that Andromeda contains 200 million resolvable stars, or rings, or streams, or a suspicious southern disorder, or even a future that may one day intersect with the Milky Way. It is that all of these things appear in one neighbouring galaxy at once, as though the nearest great spiral has been waiting just close enough to show what large galaxies are really like when resolution becomes almost unforgiving. And still the picture remains incomplete. Somewhere in the outer halo, there may be fainter streams not yet fully traced. Somewhere in the crowded inner regions, stellar populations may still be blended in ways that slightly distort the current timeline. Somewhere in the motions of the satellites, there may be evidence of older group infall or long-forgotten encounters. Somewhere in the nucleus, the quiet black hole may preserve a record of feeding episodes now barely hinted at in surrounding stars and gas. The mosaic does not close these possibilities, it authorises them. It tells astronomers that Andromeda has enough visible complexity to justify asking larger questions than before. So the galaxy remains what it has always been, but on a far deeper level. It is still the nearest great spiral. It is still a faint patch to the unaided eye under dark skies. It is still the object that once taught astronomers that the universe is larger than the Milky Way. But now it is also a resolved field of evidence, a neighbouring system whose inner light carries signs of impact, survival, renewal, and uncertainty. Hubble does not finish Andromeda. Hubble begins a more difficult way of seeing it. And the more carefully that vision advances, the more the galaxy seems to resist becoming fully known, as if its brightest gift is not clarity alone, but the permission to keep looking into a structure that only grows stranger as the details sharpen.